Right, folks, welcome to our third and final session for the data wrangling with Python, a beginner's introduction. I hope you have been finding these sessions valuable. Before we start, I would like to make a few announcements. As you know, this series is sponsored by SupportVectors AI Training Lab. Here, we provide a lot of courses, a lot of workshops and boot camps, which are quite intense. We also do offer some of these free outreach sessions. For those of you who would like to take workshops with us on the topics that are very relevant, like large language models, like MLOps or neural networks and graph neural networks, and agents, and so forth. We do have it there in the course portal. If you go to supportvectors.io, you will find the list of all our upcoming courses. These courses are all very, very hands-on. They're lab-driven, but they're also deep in the sense that we do not avoid going down to research papers and reading them carefully. So there's a lot of code, there's a lot of research paper reading. And for those of you who are leadership crowd, management, and entrepreneurship, in every course, we do have an entrepreneurial track in which you focus more on the strategic implications of those technologies in your organization. So these courses are all here. They're all about to start in a couple of weeks. Today is the first course, the MLOps, starts on August 12th. In other words, 1 week from now, not the next week, but the week after that, all these courses will start, and it will become quite a bit of fun, actually. People learn a lot. I'm proud to say that many startups have come from amongst our participants, from our alumni base. Quite literally, while they were still doing the boot camps, they would gather, become friends, and do startups. People have gotten really good job offers and gone on to the top tier graduate schools. So it's a matter of pride for us. So anyway, with those words, I'll leave it to you. The other point that I want to mention is in the course portal, you will notice that all the material is there. If you go to any one of the days, you will notice that the video for that course is mentioned. For example, the first day we covered NumPy. So here's the video on the NumPy, a session recording. Likewise, pandas, there's a session recording for pandas. And from yesterday's session, tidy data and string, data encoding and so forth. So you can, if you have registered with the site, you do have indefinite access to the site and to the videos. You can always come back and watch it. One of the things we will do shortly after the course is over is we'll put onto this course portal some quizzes. Those quizzes are for self-assessment. If you just want to check whether you are doing well or you grasp the concepts, you can take those assessments. You don't do well, then try it again and again, and then you'll master those topics. We do it not only for this very beginners workshop, our course, we do it for every single course. All of our courses have a lot of quizzes, self-assessment steps, and programming assignments, and so on and so forth. So you are getting a taste of how our workshops run. And I suppose that is all I would say. Once again, please be reminded, this session is being recorded, and it will go on for the next couple of hours. Kyle, our data scientist who has been taking you through the past two sessions, will now take over and will continue the topics from yesterday.
Yes. Good evening, everyone. Welcome to the final session on data wrangling. So on the course portal, let me share my screen. And system install. Okay. Right. Yes. So if you go to the course portal, if you see activities, there's an additional activity for today, which is labs on missing value treatment and encoding. Just click on it. It will get downloaded. unzip this file, and you'll get 2 notebooks. Just add those 2 notebooks into your project, into the Visual Studio, into the same data wrangling project that you have. So that would be the first step. So everybody has access to the course portal. Just let me know if someone has not registered, or let anyone in the teaching faculty know. So Ravi is here, you can let him know. And I see there's one question for Asif. Asif, are you still here? Okay, he just dropped off. All right. All right. So about the AI agents, Rahi, can you or Ravi, can you just find the dates for AI agents course and post it down in the chat, please?
Yeah, okay, let me check.
Yeah, thank you. All right. So for today's course, we are going to start with where we left off, which is we left off at tidy data. We're going to start with the next lesson on split, apply, combine. Then we'll be going over date time manipulation, missing value treatment, and if time permits, we'll go over the 10th notebook, which is pre-processing. You might have this notebook as encoding in your project. You can delete that notebook and paste this instead. Okay, so let's get started on this, right? So yesterday we looked at a paper by Hadley Wickham on called Tidy Data. So today we are going to start with another paper of his, which is the split, apply, combine strategy for data analysis. So in this topic, there are, I mean, this is a very, those who know SQL might find it very easy to understand. It's a well-known strategy. But for the beginners, I'll explain what it means and why do we need this strategy in the first place. So before we begin, so let me just go back to our Grand Slam data set. So if you had completed this lab, this is the final data frame that you would have got. So in this lab, we had tried to find the a subset of the original data frame, subset of the original data frame where Rafael Nadal was the winner. And we also tried to find another subset of the data frame where Roger Federer was the winner. Okay, but let's say we want to divide the entire data set into multiple parts. Let's say I want to find out how many tournaments did each of the players win. So in that case, if I go by filtering by each player, it will be a very tedious task. So that is where the concept of splitting the data frame by a column where value comes in. You split the data frame by the winner in this case, and then you perform some analysis on the each individual split, and then you put it back together. So this is the crux of split, apply, combine. The reason is whenever you want to do filtering, when you want to split your data set into multiple chunks and work on them individually, you'll use this strategy. So the strategy is used when we need to break down a bigger problem into manageable pieces and work on them separately and then put them back together. So that is what it is. So split is splitting the data into groups. Apply is applying a function to each of the group independently, and then finally combining the results back into a data frame. So there are several uses for this. One is for data preparation. Then there's another case where you want to, once you prepare the data, you want to summarize the data. And then finally, you want to do modeling on different groups of data. Now, we'll be focusing on the first two concepts here. Now, if you, the other tools other than pandas that you could use are SQL, which is probably the most popular tool to use. Then we have Excel, and then we have R. So in pandas, to do this strategy, we use a method called group by. So we'll see how we work with it. So let's say that you have a data frame of it's a very abstract one, but let's look at it. So we have a data frame with keys and values, XYZ, and values, some numbers. Now let's say I want to group by this key column, and I want to compute for the key X. I want to find the mean of the values. Like for all the values X, where the key is X, I want to find what is the mean of the value here. Okay. And to do this, we use the group by function, and we just simply say groups equals df dot group by key. So what this would do is it would group your data frame by this key column. So all the rows with the key X will form one separate group, all values, all rows with Y, and all rows with Z. So we'll have three groups in this object. So what groups is a generic data frame group by object. So and you can iterate over it. So that is the and you can iterate over each group and perform individual transformations to it. So the group by method splits the data frame into groups based on the key column and stores it in a group by object. The groups can be accessed by iterating over the group by object. So let's look at this. So if we say for name comma group in groups. So what we specify here is we specify the index and we specify the group. So I mean, when we iterate over groups, what it will return to us is a tuple of two values. One is the name of the group by object, and the name itself will be the column by which you are grouping it by. So the name is X, and the values are that subset of the data frame. So we have three groups in our case. So from these groups, we can you can also do groups dot get group, and you can specify the name of the group, right? So you can get it this way also. Now, once you have grouped by certain, once you have grouped by a certain column, the next step would be to do some transformation on those group by objects. And now we have a lot of versatility. And this is where probably, if you're more than you get more flexibility compared to SQL, is that the number of aggregate functions, you can define your own type of aggregations, you can define your own type of transformations and make it however complex you want it to be. So the simplest aggregations that we have built in are some summarizations. So for example, in this case, if we are applying aggregate, let's say we have an input, the same data frame, and we have split it into three. and we are going to aggregate it. So aggregate is where we specify how we want to process each data frame. And in this case, we want to find the mean of the B column, right? So, and when we apply this aggregate, we'll get for X, what is the, and we have to specify which column we are aggregating, right? So I want to aggregate the B column. And
Excuse me,
yeah,
Kyle, can you
yeah.
increase the font size and hide like the control bar? Thank you.
Yeah, okay. And is this too small still? The text.
If you could hide the zoom control bar on the top, the participants parts, maybe only the focus on the
Participants.
view options,
This
just focus on the content.
this one.
No,
I
you have a view options.
Can you
After
drag it to the side of the window or something?
is that okay?
It's fine,
it?
I guess.
I mean, I'm not able to hide it. That's the problem.
Just push it
okay.
all the way to the side.
Okay. All right.
Okay, I guess.
Is there any other way to deal with this? Please tell me. Okay. Right. So when we aggregate the B column by mean, we get these values. And so this would be the apply section of the split apply combine. And finally, we put them back together and we get the summary this way. So this would be the split apply combine to do aggregate over mean. So if we want to now all these steps can be done in one single line of code, and all we need to say is df.group by key and say mean dot mean. So this would group your data frame by the key column. Then now if you don't specify a specific column over which you want to compute the mean, now all the rest of the columns will all the other columns in your data frame will be aggregated by mean. So in our case, we just had one other column. So we had X, 3, Y, 4, and Z5. So are we clear? Shall we move on? Yeah. Okay. So let's look at an example, right? So this is again the gap-minder data set. And this is from the Health and Wealth of Nations homework as well. So now in the gap-minder data set, each observation is a record of the population, life expectancy, and income of each country for each year. So for every year, we're measuring these three variables for every country. So this is the data set that we have. Now we can get different kinds of summaries from this table. One would be, let's compute the mean life expectancy for each year in the data set. So what we are trying to do is, we have, let's say, around 200 countries in this table, and we have the life expectancy for each country. Now we want to find the average life expectancy, or probably the best would be to find the median life expectancy for every year. So in 1800, globally, what was the life expectancy? And to do this, it's a very simple piece of code. And we just say, now we want to group by year, right? So we want to group the entire data set by year and then find for life expectancy, what is the median or mean. So then we say, we take the data frame, we do a dot group by and specify the column by which we want to group by, and then say dot life ex. So now we specify the column which we want to aggregate. So we say dot life ex and then dot mean. So this would give us the mean life expectancy over each year. Now we can see that in 1800s it was just 31. So definitely what we have now is a huge improvement. So we can see how the life expectancy increases over the years. Now with group by, there are some several built-in aggregate methods. We have seen mean, and these are the other like aggregate methods as well. So count would count the number of values in each data frame. And this we can use, let's say if we want to find in our Grand Slam data set, we wanted to find the number of tournaments that each player has won, we would use count. Size is also similar. It counts the number of values in that individual group. Then we have mean, standard deviation, min, quantiles, sum. So you can look at the documentation to look at all these descriptive statistics and how we can use them. Now comes, okay, let's say you want to define your own aggregate method. You can do that very easily in Python. So you specify your own function, right? And in this function, what I'm doing here is a min-max scaling. So what I'm trying to do here is within that group, I'm trying to find which is the maximum and minimum value, subtract it, and then divide by the series count. So actually, this is not max scaling. No, this is not. This is just some other type of statistic. So, right. So we're getting this life expectancy dot. So how would we apply this function? So we say gapminder dot group by year dot life ex dot aggregate, and you specify your function. And then for each year, you get that particular statistic. All right. So let's say you want to do the same statistic, but you also want to get multiple. I mean, you want to group by year, but also you want to get multiple statistics or multiple types of aggregations. Then you can use this method as well. You can say lifex dot aggregate, and then you pass in a list of aggregation methods. So you can, in this, you can specify a function that you have written, some built-in functions, some numpy methods. You can use numpy also here, numpy standard deviation and numpy variance. So you have a lot of flexibility there. Then single function on multiple columns. So let's say you want to find the mean for population, income, and life expectancy together. That is also possible, and you just pass in a list of columns here. So if you note, the group by columns become the index of your data frame, and the rest of the columns would be here. So when you do a group by, the columns by which you group become the index. Now, let's say for each column, you want to apply a separate, apply an individual statistic. So you want to group by year but for population, let's say you want to find the mean population. For income, you want to find the median income. And then for life expectancy, you want to find the maximum life expectancy. So then you can also specify that using the same dot aggregate method. Like now you would pass in a dictionary, and how you want to aggregate for each column, you can specify that. So you specify the name of the column and the type of aggregation you want to do. All right. So the next, so any questions here? Or are we clear?
Is there any way we can do order by here?
Yeah.
Okay.
So group by, and then you can specify dot order by.
Oh,
Yeah.
that's okay. And when you say that year and content in the first one and the rest are all the normal column, so we are grouping year and content, right? That's all. It's a simple. How many we can do a multiple group by, and
Yes.
then whatever the column you want to aggregate it.
Yeah.
Okay. Yeah.
Yeah.
Thank
You want to group by year and continent in this case.
Okay. Thank you.
All right. So the next type is instead of aggregating, you just want to simply perform a mapping function. Like in the previous case, we saw that for every table, like first we split it into 3 data frames. And then we did some aggregation where the number of rows for each data frame, we finally got a single row. So in this case, when we do a transform, we simply map each value to another value and put it back in the data frame. So let's say we want to transform by mean. So we have in this case 0, 3, and 6. Now the values, we want to replace all these 3 values by the mean of these 3 values. We can, what we have to do is we split by the column A, and then for column B, we replace it by the mean and put it back together. So now we see that the input and the output will have the same number of rows. However, we have done some transformation to the data set. Okay, so here we're just noting the size difference, the number of rows when we do an aggregate versus a transform. So if we so the syntax is very similar. Dot aggregate mean will aggregate it. Dot transform will simply map each row to the mean. So if we do a transform, we see that the number of rows in the data frame remains the same. We don't change anything, except that we replace all the values by the mean. So let's try to solve one problem with the this gap-minded data set. How much does each continent contribute to the global income each year? So in this case, let's just assume that the total income of the world is a pie. What portion of the pie does each continent contribute? So for this, we would need to know the proportion of the global income contributed by each continent. So this is where we are going to, this would be one use case of transform. So there are actually 3 steps. The first step is we should get the total income of each continent in each year, right? To do this, that would be the first step. Let's get the total income of each continent in each year. So how would we get the total income of each continent? What would be
group by continent? Do we have sum of incomes? I'm just asking.
Yes, correct. So we will sum it up together. That's exactly what we're doing. So we're going to do gapminder.group by year continent, choose the income column and sum it. So this way we'll get the GDP of every continent. Now the next step would be to find the total income. Let's because we want to find the proportional income of each continent, right? So the next, what would we need next to solve this problem? It would be to find the sum of the income of all continents in each year, right? So we'll need to know, okay, so we have this, these are absolute values, okay. Let's sum this up together to find in each year how much was the total income. We could have done that previously also without, we just skip the continent, we'll get the by year what is the total income. But since we have this, we have done this step, let's continue from here. So so before that, let's do a reset of the index so that we bring back the year as a column instead of an index, right? So like if we had to do this in 3 steps, we could have, that is the thing. We'll first get the sum total of the income, and then we would divide each income like Africa by the sum to get the proportion of Africa's contribution, right? So to do this in one single step, we use transform. And how we use transform is this way. We get for now the next step is we are grouping by year again. So we are grouping this data frame by year. And in each year, we are going to transform the continent's GDP. So how we are going to transform is we are going to take for every row, we are going to take that row, sum all the rows in that particular group, right? And then divide. So this would give us the proportion of income for each continent. Does this make sense?
Yeah, it's like a ternary operator, correct?
Ternary operator.
You have dot transform, is it? Is a function? This
Yes,
lambda is a
so
Python function. What is this transform?
so lambda is okay. So lambda is an inline function, like yeah. So here you assume that this is a function, right? Now
Correct.
dot transform is what you need to apply in order to map each row to this function. It's a straight map. You're just mapping every row to this function.
Okay.
But in general, when we do a transform, is a row become column, column become row, right? Is it applies here also?
You mean
Previously.
transpose?
Oh, sorry, that transpose I just
Yeah.
sorry.
Yeah.
Good.
Uh,
Good that you say that.
So dot group by, and then when you say transform, the transformation is applied for that group. Like the transformation happens per group. So we are taking this, the group that we are interested in is for the year 1800. I want to find the proportion of Africa's contribution to GDP, right? So then I have to sum all of these up and then divide. So that's what we're doing here.
Is it, Kyle? We are introducing a new column right now in the data set. So this would be in this data frame,
Yes,
right?
yes.
So is transform adding that column or?
Transform, see, in data, I mean, in pandas specific, I mean, in general, whatever transformation you do will get returned. Now you can, it's up to you to added back to the data frame or not. So in this case, I am specifically adding a column called proportional GDP, and then and assigning this function to it. So this would just return a series, a panda series. Now I'm just assigning prop GDP to it. Does that answer your question?
Yeah, thanks. I was speaking in mid. You mentioned in the previous lecture that when you have to do when you're talking about reset index, you're saying that data frame, if you give the argument in place equal to true, whatever you do it gets retained in that same data frame object, right?
Yeah, but in this case, it will not.
Okay.
Yeah.
So we'll have to specifically add it to data frame and so
Yeah.
on.
Yeah.
Okay.
Now we can chain all these functions together. Like we did several steps. Now we could just chain the whole thing in one line. I mean, it's a given that it's going to make your code little unreadable. But however, this is possible. So we say, firstly, we group by year and continent, get the sum, reset the index, and then group by year, take the income column and do the transformation. So maybe if you write it in, put it in this way, you can still make this readable. You can chain these functions together like this, right? And add more. I don't think you can add comments here. So this way, probably it will. It's a little bit more readable. So the different steps you're doing. So you can have it this way also. Now let's just visualize what we have done. So I'm using a visualization package called Altair to make some interactive visualization. So what we are doing here is, for every year we have computed the proportional income. So I've plotted it out as a bar plot, and if we move from year 1800, you can see generally Europe has been always at the top as the highest contributor for the world's GDP. However, we see around this time we have for a few years we have Asia taking the lead, and then it's Europe back. Hello, can you hear me?
Yeah.
Yeah.
I'm able to hear.
Yes,
Alright.
yes, we can hear you. That's right.
Okay. So this visualization helps us, understand what we have in more clearly understand what we have done in the previous steps. So using this data set, we can create this visualization. We won't be going over the intricacies of Altair, but maybe in a data visualization course. So then we see, so that another strategy we'll look at is filtering. So let's say for each year, what are the countries that have a GDP in the 90th percentile? So for every year, we want to see which are the top performing countries of the world. So to do that, we can use the transform function to get this information, gapminder.groupby, and then transform. Again, we are passing in a lambda function. So we call it Gapminder rich, and then we get the list of so basically what this does is it gives us which is the 90th percentile, right? So we're going to add one column. We can actually have that series called Q90, and we are going to filter our data frame by Q90, right? And the Q90 is going to be different values for different columns depending on the year which we are selecting. So it's going to basically filter out all those it's going to retain all the rich countries of the world. So let's just look at the rich countries of 1800. We have Argentina, Austria, Belgium, mostly Europe. We do have United States and South Africa. And okay, this is a long list. Okay, this includes all the years. So now we do see Middle Eastern countries coming in, but Kuwait. But still, we have majority is still Europe, and we have Singapore. So yes, this keeps changing, and maybe if we can create a visualization, we'll get to see which countries pop up into the top 10. I mean, the 90th percentile.
Sorry, I have to interrupt because you don't seem to notice that your battery is going to shut down your computer very soon.
Oh yeah. Thank you. Thanks. Haha. Thanks a lot. Okay. Now we look at the apply function, the apply method. So the same can be done using the apply method in a single step. So what we did previously, we did a transform and then we did a filter. Instead, now apply is a method that is more flexible and it's super customizable. We had aggregate and transform, which are inbuilt functions, and they map in a certain way. But for apply, I mean, for aggregate, we had that for every group, it returned one row. For transform, it made sure that the same number of rows in the original data frame is retained. But in apply, it's absolutely your wish. You can return how many ever rows you want for every group. So you can do any sort of filtering and then return back. So this makes the group by operation more powerful, right? So here we are doing the same step in using apply, where we're saying for every group, take that group, filter that group by the income column, make sure that the income column, the values that you select are those countries that have an income in the 90th percentile for every group. So you do this whole step in one single line, and it gives you and that's it. You got it done. So let's next go to missing value by imputation. So we'll see how we can use group by for missing value treatment. We will go over the other methods of imputation in the missing value notebook, but here let's see how we can use group by for missing values. So let's look at this data set called Melbourne housing data set. In this housing data set, we have, these are the variables, and what we want to predict is the price of selling price of a house. So now these are the variables we have. We have the number of rooms, price in dollars, method by which it was sold, what type of house is it? Is it a cottage villa, which is a house? This is one category. Is it a unit? It's a townhouse. And then we have date, distance, region, property count, bedrooms, car, land size, and a bunch of other columns. So let's load that data set. And since we have a lot of columns, I'm just going to transpose it so that we see the first 5 rows. Right? So this is how the data set looks. And let's view a few rows from the end. Now let's look at the missing values of this data frame. So we'll use this in the missing value treatment notebook as well. So this is this missing number is a library that helps us visualize missing values in our data set. Right, so we can see that almost all of them are we don't have any missing values, but we have building area and year built alone, we have a few missing values, and some council area and all that. Okay, so this gives us some, and also here we see the exact number of missing values. But for our purpose, I'm going to add manufacture some missing values to explain how we can use group by for filling and missing values. So in this case, I'm going to randomly take out some 200 values from the bathroom column. Okay, so once we do it, we see that we have introduced some null values into this column. Now our goal is to impute the missing values of the bathroom column by its median, right? So bathroom, let's just go back and see what it is. It gives us the number of bathrooms in the house. So let's say we have a bunch of missing values, and right? So how would we fill in these missing values if we do not know how many bathrooms are there? Suppose we want to, we can make some, educated, like we can make some prediction, or we can just come up with our own idea or intuition of how to solve this problem. One way would to say, let's say that the number of rooms and the type of house have an influence on the number of bathrooms in the data set. Okay, let's say if it's a flat, or if it's an apartment, then it may have certain number of and that apartment has 2 rooms. Then that group of houses, or that group of rental properties may have a similar number of bathrooms. And similarly for each type of house and the number of rooms in the number of rooms in that type of house, we can predict the number of bathrooms. So what we can do here is we can group our data set by rooms and type, find the median number of bathrooms, and then fill in those values when we are trying to remove the missing values. So to do that, let's just write our own function called fill median. Okay, so given so X here, I think should make it a little bit more explicit. It is a pd.data frame. Okay, so given a data frame, we are going to find the median of that. I think it's a series. We're going to find the median of that series And then for that series, we are going to fill the missing values by that median. Okay. So given a series, we want to do this step. So let's then go ahead and group our data frame by rooms and type, and then select the bathroom column. Okay. And then, so now in our grouped, we will have multiple groups, and one group for every combination of room and type. Right. So let's just look at it. I think these are some codes, and if you look at the documentation, you'll get to know which type of house it is. So we have one room, and this is of I think it's probably mentioned here. Yeah, H T dev site and other residential. So let's say we have for H and 1, the number of rows that we have is 58. And similarly, for every group, we are just counting the number of values in that row. I mean, a number of rows in that group. All right. So then we are doing some, and then finally we are filling in the missing values here. Okay. So this is the first step. We are splitting, and then here we're doing apply and combine, where we are basically transforming by our own function here, fill median. Okay. So this would get us the this would fill in the median values for the bathroom column. So this is one way how we can use group by to impute missing values. All right, so that brings us to the end of this session. I mean, at end of this lesson. Any questions? After this, we'll take a short break and then come back. Okay, so I think we can take a break, and let's say what time? 8:20 p.m. PST. Let's take some 20 minutes. Should be 8:50 India time.
Yep. Thank you.
Okay.
We'll be back.
Yeah, sure. Hi, Damu. Were you able to work on the lab yesterday? String manipulation or Dilaver? Anyone? I think they're away. All right.
No, I'm sorry. I couldn't get time on the string
Okay.
manipulation,
Mm-hmm.
but I did lab one to an
Oh,
extent.
nice.
Yeah,
Nice. So you got it working.
yeah.
Awesome. Do you want to share the solution? You can just, those are here. You can just look at your notebook. You can share your screen.
Sorry, I was saying I'm taking the call from mobile Zoom.
Ah, okay, sure.
Sorry,
No
today
issues.
I was out and
Haha.
Saturday. So
All right. Yeah. Anyone else worked on the lab work? Do take time to do it so that you don't forget what we've learned in this class. And this will come in handy for the upcoming courses as well. If you're comfortable with pandas, you'll be comfortable with you'll be comfortable with the MLOps course also.
Hey, Kayal, I shared with you how to hide the.
Yeah, let me try it
I don't
out.
know if it will work or not, but that's what I found.
Yeah, let me see. Okay, which screen am I sharing? Okay. More. I don't see it. Hide floating. Right? Is there some advanced sharing options? No. Have they changed the name for it or something?
I don't see
Default.
anything on there that would imply that. Okay,
Mm.
let's try something else. Can you grab the one of the
Yeah.
edges, not the middle, from
Mm.
the edge, and then just move it all the way to the side? No, grab the edge of the control bar, not the middle of it. No, grab the left or the right edge and then
Okay.
move it to the other side. There
Okay.
you go.
Got it.
If you can't,
Okay.
yeah.
Nice. Yep. Got it. I do remember seeing remove floating panel, but it seems to have disappeared. How do I open the chat? Okay, got it. Okay, so we will start in a couple of minutes. Is everyone back at their desk? Just put a thumbs up sign so that I know you're available. Okay, Gaurish is here. Or just put a message on the chat. Okay, we have Damu. All right, I think we can get started. So the next section we're going to cover is on time series and date functionality. For this, we'll look at some methods for date time manipulation. So to deal with date time in pandas, we use the date time components. It's actually a huge topic and we have a lot of functions, and there's a lot of documentation available and you can refer to them. But here we're just going to cover some very basics that will help you get started to work with the time series. So there are 4 general time related concepts in pandas. So the first one is called a date time, and this refers to a specific date and time which has a time zone support. So this is the most used data type. So we have a date time, and you would have, this is how it would look like, right? So you can convert any string to a date time object, right? So and when you convert to date time, the data type is a timestamp. The second is time deltas and absolute time duration. So let's say the month of August of 2024 is an absolute time duration, right? So as in it has it's an actual time duration. So it's not just a month, but it is the month of August in 2024. So that becomes a time delta. So let's look at I'm sorry, that's a time span. So if we have a period, PD dot period Jan of 2020, then that is that becomes a period, right? So then we have time deltas and date offsets. So these are a sort of similar, they are time durations, but they are sort of they help us work with date time and time spans. So let's look at time delta and date offset. So if we see time delta shifts a date time by a corresponding calendar duration period. So let's say PD dot time delta and days equals 1. So this would become 1 days. So this was a sort of um, it measures a day. So then we can say date time plus time delta. So we have we have a date, and then we can just add 1 day to that date, and we will get the next day, right? So we can add days to our date time. Then we have date offsets. So we have a lot of documentation on what date offsets are. I think we have mentioned, yeah. So there's this user guide. Just open it. Okay. So everything, it's like well documented, and you get uh, a lot of things we cover in this section are from this documentation. So you can refer to that documentation and work with it. So the date offset is also like time delta, but it is it's specific calendar durations. Like you can say business days, right? So or weekends. So it has a calendar meaning to it. So we can say date plus 2 times 2 business days. Just add 2 business days. So if we have a date, a Friday, then if we add 2 business days, we get Tuesday, right? So we get that functionality as well. Now let's just work with some, a data set to get a hang of these data types. So let's use the same weather data set that we had worked with earlier. So New Orleans Lakefront Airport weather data set. And these are the columns. We have the average wind speed, precipitation, minimum and maximum temperatures. Okay, so firstly, we see that this is a date column, right? But when you load the data, it will get loaded as an object, because this would be considered a string. So it will get loaded as an object. Now, to access all the datetime functionalities, you need to convert it into a datetime object. So the way you do it is, say pd.datetime to datetime, you pass in the column. And additional parameter is you can specify what type of format you want it to be in, right? I specify the format, but why is it not that format? Let's interesting. Okay, probably we need to figure out why this is not working. Okay, do let me know when you work on this, when you go through this lab, as to why this format or function is not working. So when we convert a column to a date time, it is converted into a datetime 64 ns. Here ns refers to nanoseconds. So in actuality, this date is captured along with the hours, minutes, seconds, milliseconds, and nanoseconds, right? Yeah. So then let's convert to date time. Well, now we did this individually for this particular column. We can convert the date time while we import the data itself. So let's say you want to convert, you want to parse the dates from this CSV file. You specify the column and you specify a function to parse that column, right? So this gets parsed while you load the data itself. And then there are some accessing some date time attributes. Now, if you want to, like for a timestamp object, if you want to access its year, all you need to do is say .year. So in this case, I'm just taking one value from that data frame. So it's a single value from the data frame. And if I say .year, I will get the year component. But if you want to access the date time features for an entire column or a Panda series, you can use the .dt accessor. So it's very similar to how for strings we had .string. Here we have .dt. And if we say date, you take a series and say .dt .month, you get the month of that series. Okay. So then let's look at how we can filter dates. So to filter dates, all we need to do is you can filter using a string. So data, you take a column and then you specify the filter, right? So then you can select based on the filter. You can also filter, I mean, this would be the most obvious, like if you have a timestamp, you can filter on this timestamp as well. If it's a string or a timestamp, you can work with it. Then there is you can do some filtering and slicing. So if you want to filter or slice based on a date column, you should make sure that the date is the index. So generally, index would be just numerical, but we have seen cases where we would need sorry, is someone saying something? Okay. All right. So we have we need to convert this column into an index so that we can do some filtering and slicing based on this index, right? So let's say we want to select all the data between two dates. Then this becomes very simple. We say, right? We specify the range and we'll get it. Now, similar to group by, we just in the previous section we saw group by. Now group by was for any or based on any column, but in the case of date time objects, we use something called resampling. It's exactly identical to group by, but in time series context we call it resampling. So let's just take this column. We have the maximum temperatures recorded on each day, right? And we have this information for a whole year. Now, let's say we want to find the maximum temperature recorded for each month, right? So how would we do that? Ideally what we'll do, we'll just group by the date column, right? And then find the maximum group by date, but right now we don't have another column called month, right? So this is where resampling helps us. We can resample based on month using a simple syntax and just say tmax.resample, and we specify a rule. And the rule is, we have a bunch of the rules could be passed in as strings, and we have that information here, right? You can just check what all date offsets you can specify to resample your series, right? So in our case, it was by month, so we specified M. And once you resample, it is going to be similar to a group by object. It's going to store, it's going to split your data frame into multiple groups, and you can iterate over them, or you could, once you have them split, you can apply an aggregate function. So in this case, we are saying tmax dot resample M and then dot max. All right. So then you could also, very similar to group by, you can resample based on month, but then work with each column. So for each column, you can specify the type of aggregation you want to do, right? So you would say for average wind speed, it makes sense to get the average wind speed of the month. For precipitation, it would make sense that you get the sum total of precipitation for that month. For Tmin, minimum of the month, Tmax, and maximum of the month. So now you have resampled it. And so for every month, we have the average wind speed, total, sum total precipitation, month, and minimum temperature and maximum temperature. However, here date doesn't make sense because we are actually talking in terms of a period. So we can convert a date to a period as shown here, right? So we are changing the index from date to period. So period, and we specify the date, the time delta. So now we specify this and we get, actually this shouldn't be called date. We can remove this. So so this would be the 2021-01. So for Jan, so we have the month information here in the index. So this makes more sense than having the date itself, right? All right. So next is doing some calculations with dates. This is going to be a little little, a lot of transformations are there in this data set. So I'm just going to go over it quickly, and so that we can move on to the next lesson as well. So in this, we have, so we're going to introduce a new data set called Ebola data set. If you have worked in, if you have used some standard data sets, this is one of the standard data sets for learning data science. So the Ebola data set records the case count and death count of 8 countries, including these 8 countries, right, from March of 2014. So how this data set is arranged is that we from March of 2014, we are looking at the number of cases of Ebola cases starting from March, and we are recording the number of days, let's say 90, sorry, where's the data set? Let me run everything above. And wait. What's happening? Yes. Okay. So we have a date, and then we have the number of days from March 2014. And then we have the number of cases in each of the country. Now we can see that this is not a tidy data because again, we have, I mean, why is it not tidy? It has variables, it has values in as variables, right? So ideally, we would want to convert it, have a new column called cases, and then country, right? So country and cases would make more sense, but this is how the data set is arranged. Now, and this, so what I wanted to say here is that these numbers, these days, like they don't measure the number of case counts every day. So they just pick a random day from the start, and then they measure the number of cases. And this, the day that they pick differs for each country. So each country picks a, I mean, they measure the number of cases on a different day. So we are just noting down from the start of, like, from March 2014, how many days has passed since the record was made. So this information is provided here. So we want to just clean up the data set and work. So for the first thing we would want to do is convert the the date column to a datetime data type. So that is simple, right? And we are going to set the date as the index. So we're going to do a lot of date transformation. So we want to set date as the index. So I've just transposed it, right? Just to show that, so this is the index and these are the columns. And mostly we have a lot of NaN values, because let's say on this day, Guinea recorded its number of cases, but not necessarily Nigeria would do the same thing. So for every date, we have a few records, and for most of them, it would be NaN, right? And then we are also looking at the end of the data set. So one thing we do notice is that, okay, we start from 2015 and we have all the dates going back to 22nd March of 2014, right? So we have every day up to 2015. So we have it covers some 8-9 months, right? So some 10 months, I guess. So in this case, so the dates are arranged in descending order. The date range contains a few missing dates. So actually there are some dates that are missing. Even here, we do have some missing dates. For example, 30th March is missing here, right? So there are some missing dates in the date column, and the dates are arranged in descending order. The frequency of the cases and deaths have not been recorded on these dates. For example, 2014-03-23 is missing, right? So all countries do not have the same start date of the outbreak. Yes. So if you see, we have Guinea, which has started recording from March 22nd, but not necessarily the outbreak hasn't yet started in other countries. So we have a lot of missing values here. So our goal for this exercise is to compare the speed at which the disease spread in each country. So what we want to see is, let's say we have a baseline. We have the 0th day, the outbreak day for each country, and we want to start there. And we want to map how the case counts have increased from the 0th day. So right now, this data set is arranged in such a way that the outbreak day is different for every country, but we want to make sure that each country starts at the same baseline. So then we are going to talk in terms of days instead of the actual date itself. So the 0th day, and starting from 0 till they stopped recording. So to do this, we will manipulate the data set as follows. We'll create a new index containing all the dates, right, using pd.date range, and arrange in ascending order for convenience. So firstly, we're going to fill in those missing dates that are not present. So we're going to add nan values there in case, since there was no record of that date. So the first thing is we're going to create a new index and make sure that we fill in the missing values. Then we're going to get the day 0 of outbreak for each country. So we're going to get on which day the outbreak started. And then we're going to make sure that we use the day as the index and calculate from day 0 what was the case count for each country. So to do this, we do a bunch of manipulations, right? So we are creating a new index using date range. This would it would create a range of dates from the minimum till maximum with D, right? And then we're going to reindex. So reindex is it will insert new rows, insert new records, and those records will be filled with nan in case we don't have any data for it. So we are doing data.reindex and new index. So this becomes our new data frame. So we notice that 2014 0323 has been added. So we have a new row for this. So right now we have every date from 2014 till 2015. Now we find the day 0 of the outbreak. So some more manipulation to get, okay, so this tells us that in Liberia, the outbreak started on 27th. United States, it started like several months later, right, in October. So we get all this information. Now we are going to create the baseline. We are going to say, okay, let's say it started on the same day. How did each country handle this Ebola? So we're going to do some more manipulation, shifting around the index. So I think you can go over these things in detail. So I'm going to just skip over this. And in the end, this is what we get. So we have the first day, 0th day, and then first day, second day, and then on we have the case counts arranged this way, right? So we have on day 0 there are 49, and then 86, and then it keeps going up. So considering all countries have the same baseline, right? So now let's just plot this information, and voila, there's almost nothing, right? So most countries don't measure on every day. So they just measure a few for a few consecutive days, and then and do not measure, right? So, but we have some amount of information here, and we just see like starting from day 0 till around 200, around 231 days we have, and probably a little bit more. So for about approximately a year, how did each country handle the cases? Now we see that there are just so many missing values. So ideally what we want to do is fill in those missing values and see how each country has handled Ebola cases, right? So we'll just see this in the missing values notebook. Let me just quickly go over there. And before we look at other types of missing value treatment, let me just go to how we handle it for Ebola. So yes, so the first missing value treatment we learn is, since we are starting with datetime, is interpolation. So interpolation is a method to estimate unknown values that fall within a range of known data points. So that is the exact case we have here. We have a certain range of values. Now we want to just fill in these values, and assuming that, this assumption we can, the type of interpolation can differ, but generally we just want to fill in values that, sort of that are missing here. So just imagine that we want to draw lines between these points so that we can get that missing values. So to do that, we are just going to simply import the same data set here, and let's do so in this case I've taken polynomial. Let's just do okay, let me just do, okay, just run everything above. Okay, right? So if I do interpolate, so here what I'm doing is, for every column, I'm now every column is like cases, like for each country there is one column. So for every column I'm going to do interpolate, right? And I'm doing linear interpolation, so it's just going to simply linearly interpolate, and the direction is forward. And when we do this interpolation, this is the data set we get. So now it is more readable, and we kind of understand how each country performed. So we see that United States sort of handled it very well. So the cases, this case count didn't increase at all. But there are these three countries, Sierra Leone, and Liberia and Guinea, the case counts, they started off slow and then they just really shoot it up, right? So this information, this data, we were able to transform the data from its original form using a lot of data manipulation and interpolation to get this final visualization, right? So it is a little, data wrangling is a lot of manual work. So this is interpolation. So let's just go over the other types of missing value treatments. So yeah, the missing value treatments, there are, the real world data often has a lot of missing values. Now, the reason for missing values, there could be n number of reasons why we have missing values. But in this section, we're going to see a few methods of dealing with missing values, and for different types of cases. So, right, so we're going to load the Ames housing data set. It is also another, we saw Melbourne housing. Now this is an Iowa housing data set, and we are bringing in, it has some 79 variables. So we're going to fill in some missing values from that data set. Okay, so I'm going to introduce a missing values just for this session. I'm going to introduce some missing values into a certain column here. And now let's look at the data set. And actually this data set, if you go to this link, you'll see what the individual columns, a description of the individual columns, and what are the values that are different values that are provided in the column. So this is mostly the data set has categorical variables. So we'll look at some categorical variables and some numerical variable missing value treatments. So if we look at the data set, we have a lot of columns, right? So, and the columns values, are usually, the columns are different, features by which you can measure um, the individual house. So we have lot frontage, lot area, street, alley, and all of that. So just going to describe the data set. And now let's check for missing values, right? So we're importing the missing number library. This gives us visually for each column, where do we have the missing values? And here we can see which columns have missing values, right? So this kind of helps us. Okay, so which column? So if we have a data set like this, we may want to first focus on, all right, do we need these variables at all? They have so many missing values, maybe we should throw them away. So, right, so the first thing is, let's look at what we need to do with these variables, and maybe then let's look at the other ones. So in our case, we'll be focusing on the columns that have missing values. So to get the list of missing values directly from using a pandas data frame, you can filter out the missing values, right? Like create a filter to identify columns with missing values, and then print out the percentage of missing values in each column. So yes, so now that is done, the first strategy would be to delete the column in case the column is completely useless, or it has not much information that we could use. One of the easiest way is to just delete the column and go ahead with the other columns, right? So in this case, let's take a look at the feature miscellaneous feature. And we look at the documentation. It has these 5-6 values, right? There are no miscellaneous features. Most of them would be that. Is there a tennis court? Is there a shed? These are like some very random, features that probably will not help us, identify this selling price of the house. Also because, so if we see the number of missing values in, the number of actual values we have for each of the categories, I mean, we're seeing the proportion here. 96% are null values, and we have very small proportion of values that exist. So there are not enough samples for each of these categories to actually influence the training, right? So there are not enough samples. And the simplest way to deal with columns that have mostly missing values is to simply drop it. So, but this technique should be done with caution, so that we do not drop columns that could have some valuable information for training. So that is done case by case, and it depends on your data set and how you prefer to choose your training. The second would be to create a new category for missing values. So let's look at the alley variable. And if we look at what it means, it tells us the types of alley access to the property. So we have gravel, paved, no alley access. So what we see is NA actually means something. NA means that there is no alley access. So while the other two are actually, they tell us that there is a paved alley or there's a gravel alley. The other one is no alley access. So probably a better way to deal with this type of missing values is to just add another category called none. Instead of having it as a null value, we can specify some value and have it there. So we have a data alley, and then we fill the missing values with a string called none. So when we choose to train our model, this would become its own category. The third is imputation. So now imputation can be done for both categorical and numerical variables. So let's take a look at the electrical system feature. So if you look at it from the documentation, these are the 5 values that that are there. And if we look at the proportion of values, we see that 87% is the standard circuit breaker. And then you have fuse box, and we have different versions of average, poor, fair, and poor. But the standard circuit breakers is the most common, 0.877. And if we have a few missing values in this case, we can sort of make an educated guess that probably those that are missing will also have the standard circuit breaker. And if we want to use this variable and we want to fill it up, this would probably be the most ideal option, right? So we fill it with the most frequent class. So to do that, we can just directly say fill NA by that value, or else we can use another library called scikit-learn to impute the most frequent. So scikit-learn provides some imputation options, and the simple imputer has several strategies that you can use. So here we're using the most frequent. So what will happen is it would fit in the most frequent value into the missing values. So right, so now if we after imputing, we do a fit transform. So we'll look at this in the next session. I mean, in the next lesson, we have explanation for what fit transform means, and we'll look at more scikit-learn transformations. So here, simply what we're trying to do is we're trying to fill in the missing value with most frequent. So once we fill it, our percentage of the standard breaker increases, and we have no more missing values. Now we can do the same imputation for numerical variables, wherein we fill in the missing values using a representative. So the simplest case would be to impute with a constant value or a statistic, which is a mean, median, or mode, right? So so for that column, we for the non-null values, we find the statistic and then fill it with it. So this is also another strategy. Now there are more complex strategies where in this case, we are just using the information of the same column. We could use the information from other columns as well. And try to predict the value of the missing value. Predict the missing value. So here there's a documentation on that. So there are different types of imputers. We covered the simple imputer. There's a k-NN imputer and iterative imputer. You can check and read the documentation to learn more about it. So this we will not be covering. And then we have interpolation, which we just saw, right? So this is the last and final technique. So once we do interpolation, this is how our data looks. So these are the 5 most basic and simple techniques to fill in missing values. There are many more methods to fill in, but these are some simple methods that can get you started. All right. So the next chapter is pre-processing. It's going to be a short lesson, and I think with this we will end the course. So so far we have seen how to bring our data into a tidy format, and then treated some missing values, right? So at this stage, our data is still not ready to be put into the model, and we have to make some more pre-processing. There is still some amount of pre-processing left before we can, train a model on it. So in this lesson, we'll look at how we can transform our categorical variables into a format that we can be used for training. Okay, so we're going to look at a coffee data set. So this is just a manufactured data set, right? Like, let's say that you are the manager of a coffee shop and you want to understand what factors most influence customer satisfaction and tailor the offerings accordingly. So to do that, you want to train a machine learning model to predict customer rating based on the type of coffee, quantity ordered, and customer's identity. So let's say you have 5 different customers and you have like some 5 different types of coffee. You want to understand and you have some data on, okay, Eve has ordered a latte, large latte, and has given a rating 4. What would she, give rating for cappuccino, right? So, or cappuccino small. So these are, you want to, so that you identify what is the preference of the customer, and then you want to give some, probably some offerings to them or give them recommendations. So to do this, we have to train this, train on this data set. So, but before training, we have to make sure that, a machine can even understand the difference between a latte and a cappuccino, right? So that's where we come into the lesson of encoding. So encoding, so machines cannot understand categorical variables like the way they understand numbers. So which is why we need to convert them into meaningful numerical representation, i.e. encode them, right? So the first one would be, there are several different techniques to encode your variable. The first one would be to simply give them unique numbers. So in our case, let's try to encode the customer variable, the customer feature. So if we have Alice, Bob, Charlie, ABCDE, we can just simply give them each one number, 0, some one ID, right? So just by giving an ID, we have converted into encoding. So the way we do that is, we have a sklearn's pre-processing library, and we are importing a label encoder. So we're going to say customer encoder. We're creating an object of the class. And once we create it, we can then fit a data to it. So what we are trying to do here is, we take the data set, and when we say we fit it, we are actually creating a mapping of each unique customer in this list to a number. So internally, this encoder will have those mappings stored now once we do fit. And when we say transform, it's going to apply that mapping to that particular series. So when we say fit transform, it's going to do that together, where we fit, where we first create a mapping, and then the mapping is going to get applied to each of the values in that column. So that is encoding. So we label encoding. So we have converted this array of customers into this array of numbers, right? So then we can do this to, if we want to bring back the values, we just say inverse transform, and we'll get the names back. If you want to do it together, we say fit transform, and it is done in all in one step, right? And let's just put the customer ID instead of the customer back into our data frame. We're creating a new data frame called encoded coffee DF, and we have the customers. Now, the second type of encoding is one-hot encoding. So this method of encoding creates an indicator column for each category in the original column. So what we are going to do is, let's say we take coffee type. We want to create one column for each, each variable, each value here. So this way we are actually creating an indicator column. So we want to let's just see how an indicator column would look. So this would tell me this would indicate coffee type Americano. So it's going to indicate if it's a type of which row has Americano, cappuccino, espresso, latte, and mocha, right? So one hot encoding helps us. Let's say in our model, we want to identify, we want to train in such a way that we pass these columns as individual features, right? So in that case, we can do one hot encoding this way. So to do one hot encoding, we just retrieve the names of the new column. Okay, it's already done. So one hot encoding, you import the one hot encoder from scikit-learn, and you say fit transform. And once you do fit transform, you get an array of numbers like this. Now you can put back this array into your data frame. Ideally, this is not how you do it. So we'll see how in actual if you want to do a bunch of column transformations, how you would do it. So now we put them back into our data set, right? So we have customer and the one hot encoded column of coffee type. Now we have the last type is ordinal encoding. So we have the quantity, we have large, medium, and small. So unlike customer, where we could just pass in any ID to any person, there's actually a relationship between small, medium, and large, right? So it would make more sense to have probably small as 0, medium as 1, and large as 2. And this relationship could be useful in our training. So when we want to do encoding this way, we use something called an ordinal encoder. An ordinal encoder, you can pass in the actual list of values in the order that you want it to be encoded. So in this case, it will be 0, 1, and 2, right? So to do ordinal encoding, we import the ordinal encoder. We pass in the categories that we want, right? And what the type of encoding, we want an integer encoding or float, or which data type we can specify. So if we do the quantity encoder, we do a fit transform. So it again maps and then transforms your series. We get this final array, right? So now let's put it back into our data set. So finally, what we have is from a completely, we had 3 columns of categorical variables. Now we've completely converted into encodings so that we are going to use this for our training. Now, while we have done this individually, scikit-learn provides us an option to do all of them together, right? So we don't have to get concerned with converting it into an array, encoding and then putting it back into our data set. It is a long, tedious process. So instead, you would use something called a column transformer. A column transformer transforms each column in your data set. So you can specify how you want to transform your column by specifying the name of the column or the list of columns you want to use, apply that transformation on. So in our case, we wanted to use here, if you I mean, you could use ordinal encoder for label encoding also. If you just don't specify any categories, then the column transformer will take care of the encoding for you and assign its own values. So it will be random. So if what we do here is we pass in the list of columns, right? So we want to do like label encoding for the customer column. We want one hot encoding for the coffee type, and we want the ordinal encoding for the quantity. Remaining columns, we don't want to do anything. So we're just going to say remaining columns, just let it pass through. Don't do any transformation. So if we specify this column transformer and we just say ct.fit transform the entire data frame, we get what we wanted, right? We get the customers encoded, we get the coffee types encoded, and we get the quantity encoded, while keeping the ratings as they are. So this is like a very simple and elegant way of doing your transformations. There are many more transformers in the scikit-learn library. We haven't covered that, so but we will not be covering the other types of transformers here. But you will see this in the upcoming courses a lot of doing transformations to columns simultaneously. So with that, we end this course. I know that I kind of rushed a little bit towards the end, but I just wanted to finish everything. And I think we have some spare time. So let me know if you have any questions. But that is the end of the course. If you want, you can stay back and work on the labs. I'll be here for a couple, like at least till 9:30 p.m. PST.
Oh, just for understanding purpose, Kyle, like the market, there's so many tools available, right? Like a Tableau. Another thing is when you compare with the Tableau, another thing, I know that Tableau is for the reporting, right? But uh, pandas, even whatever do it on the pandas, like Tableau can do that.
I haven't worked with Tableau, so I wouldn't know. But I know some data transformations are possible with Tableau, like grouping by and I think even missing value treatment is there. I've very briefly worked in Tableau, so I think you can do all of that in Tableau. But you should know that Tableau is mainly for data visualization, and like you don't get the amount of customization that you can do with pandas, right? Like everything is pre-built. You can use group by on a certain column. You can just, it's very user friendly. You can just select the columns that you want to group by or you want to filter. All these things are available, but with pandas, like the flexibility is huge. You can maybe for simpler data sets that just Tableau will work. But if you really like, for example, this Ebola data set, to do all these transformations, it's just probably easier to do in pandas, where you get so much customization to work with. You have a lot of tools, and you can create your own types of transformations. So I'd say for data science, pandas is still necessary.
Okay. Yeah, I just want to understand that because so many people are like in the data science community or in the reporting side, they're using Tableau.
Yeah,
Keep
for
talking about
business
Tableau.
analysis, we are not like creating reports. That is not what we are doing here, right? We are doing data science, so still we have to use pandas or
Okay.
yeah.
Thank you, Gareth. Thank you so much for your thing. Like probably next class is Hasib is going to take, right? For the LLM basics.
Yes.
Okay.
uh yes, Asif will be taking the courses, and obviously it will be much better than.
No, definitely. No,
Yeah,
no. This, I'm not
yeah.
saying that one, but in general, I'm saying for the next course, you did a good job.
Yeah.
Good.
Thank you. Yes, so Asif will be conducting the courses. Also, the LLM and MLOps and LLM Ops course. Chandar will be taking the lab sessions mostly, and myself, we have Rahi, we have Ravi here, we have Shreya. All of us will be teaching assistants, so you'll be working with us a lot in the upcoming courses. Well, Asif will take the main theory, and we'll go deep into the concepts behind all the topics, while the lab sessions, Chandar will be taking them. Yeah.
Okay. The doctor, I forgot his name. He's still available. I want to talk to him. Forgot his name.
Patrick.
No, not Patrick. The last, no, he's in California. Doctor is Rappel. Rappel.
Oh yeah, Rapal. Yes.
Rappel. Okay. So
Right,
you
right.
have any contact? How do I want to contact him? Because I'm also in the healthcare side. I need to the
Okay.
next the LLM one I'm planning to take, but I want to do some project on in the medical side. That's
Okay.
the reason I want to get some kind of instruction from him to do something. I have some idea, so I want to work with him
Okay.
because he's a doctor, like so that get an idea. So I just need a contact. Maybe I can get it
Okay.
from. You have any contact, or I can talk to Asif also.
Are you on Discord? You can probably just message him.
Oh, okay,
He should be
okay,
there on Discord.
okay. I'll log into that, and I
Mm-hmm.
didn't log in, but I'll log into.
Yeah. Please join our Discord channel. It's
I can use. I need to
session.
create a new one, or I can use the app.
You can
App must be there, right? Discord is a general one. I think app. It's kind of channel based. Let me check that, and I'll log in.
the full name is Suppal Rapal.
Okay,
Suppal
Supal. Okay,
Rapal. Right.
okay.
Yep. All right. So,
Thank you.
and
Thank you,
since
Kevin.
the live streaming is still on, maybe we should end this meeting so that,
Okay.
or I don't know how, Rahi, do you know how to switch off the live streaming?
No, it will be done automatically. So let's close this
Okay.
meeting. Yeah.
All right then. Yeah. Okay.
Yeah.
So
Thank you all, folks.
please do work on the lab sessions, and let us know if you get stuck. We'll help you out. Okay.
Thank you all.
Yep. Thanks everyone. Hope you had a good session. Yep. All right.
Thank you.
Bye.
Thanks, Kyle. Bye.
Yep. Thank you. Okay, I'm going to end the session. Thank you.